All right, so let's talk about the Incenter. This is actually the second lesson, 5.2, but we broke it into two things. Okay, today is the Incenter. I'll give you a sneak peek of what's tomorrow. It's kind of weird. We did circumcenter, orthocenter, incenter. Well, the next thing doesn't have center in it. Well, it kind of does, a little bit. Kind of does. All right, it's called the centroid. So that's kind of weird. All right. All right, so that's what's next. All right, we're not going to talk about that today. We're just going to deal with the Incenter today. Everybody with me now? All right, let's talk about a word first before we get into the Incenter. Let's say I had an angle. So this time we're going to deal with the angle in the triangle. All right, because all four of these deals with triangles, okay? The first two dealt with triangles. The second two deal with triangles. All right, but this one, we're not finding the perpendicular bisector. We're not finding the altitude. What we're doing is we're taking this angle right here, and we're going to split the angle in half in two equal angles. Okay, that means, give me a good geometry word for doing that. What do we do to it? What's a good geometry word that says that we split this in half? So if I made, say it, Amaya. Very good, that's what I want. That thing right there, you see that line? Technically, it's a ray because all of these are rays for an angle, all right? But if I made this angle right here equal to this angle right here, what does that ray, what does that line right there do? Say the word again, Amaya. Bisects, okay? So we're going to bisect an angle. And that's what we're going to do on all three angles of my triangle, all right? So we're going to bisect the angle. Again, what does that mean? We split the angle into what? Into half. Or you could say into two equal angles. That's splitting it in half though, isn't it? Yes? Okay. So that's what we're going to do. We're going to bisect an angle. Everybody understand what bisect means? Okay. What if this whole angle was 40 degrees? I'll call this angle 1, call this angle 2. What's angle 1 equal to if this thing bisects it? It's 20, exactly. So that's 20 degrees. All right, it's not that hard. What's angle 2 going to be? It's also going to be 20 degrees, right? Because it splits it in half. Everybody with me on that? Yeah, easy. All right, so now let's go to GeoGebra. I've got to bring it up on YouTube so we can see it. We got that. We got that. There we go. All right, so now, whoops, there we go. GeoGebra, where? Click. Okay. What we're going to do is I'm just going to show you how to bisect an angle with this. So I believe, I tell you what, let's just start with the triangle, okay? I'm not going to do anything else. Oops. For some reason, when I use this pen with this program, it makes it look really weird. So I'm going to use the mouse pad thing. There we go. That's what I want. So I'm just going to some random triangle. Nothing special about it, all right? If I wanted to, I could move it around. I could move it around like this. I could take this and move it around, whatever, all right? What do you think I'm going to do with what I just said earlier? What do you think I'm going to do to all three of these angles? I'm going to what? I'm going to bisect all three of those angles. Take a wild guess. What do you think's going to happen when I bisect each of those three angles? Bisect this one, this one, this one. They're all going to be what? They're going to meet up. What's the good geometry word that we use when they all meet up and they intersect in one point? They are what? Those lines are, I said it once today, I said it a couple times yesterday. Concurrent. Concurrent. We use that word like early on, like the first week of school, I think. The first chapter, I think, we talked about being concurrent. What does that mean? It means several lines, right? They just intersect at one point. That means they are concurrent. Got it? Okay. So that's what we're going to do. Well, this program is kind of cool because it's got a little thing right there. Look at that. Angle bisector. See that little button or whatever you call that thing right there? So what I'm going to do is I'm going to click angle bisector, and I'm going to click this side, and then I'm going to click this side, and guess what it's going to do to that angle A? It's going to bisect it. Boom, there it is. For some reason, they put this perpendicular line there. I'm not really sure. We're going to get rid of it in a minute, okay? So we're going to get rid of a lot of these lines. We're going to do that to all three, okay? And all three, they're going to meet at one point, okay? And that's going to be my what? What's that point where they all meet? It's the name of the lesson. Incenter. It's going to be the incenter, all right? So I bisected this angle. So what do you think is true about this little skinny angle right there and this little skinny angle right there? They're the same. Exactly right. Everybody with me? All right. So now let's bisect this angle. So I click on this side, I click on this side, bam, it bisects it. All right, it's kind of nice, and it's perfectly bisected. I mean, it's right in the middle. So that angle and that angle are exactly the same. Let's do it to angle C. Boom, boom, right there. Got a lot of lines flying all over the place, don't we? Okay, we're going to get rid of a lot of those lines to make it look a little better. But how did we find that point? Notice, check out that point. All three of those lines intersect at that point, don't they? So that means all those lines are what? Concurrent, okay? So let's put a point there, and let's name that point. I'm going to, instead of call it D, what am I going to call it? Incenter. All right, there we go. So that point right there is the incenter. We got a lot of lines flying around. For some reason, they put a perpendicular line to this. I'm not really sure why, but let's just get rid of a lot of that stuff. I think these, if I unclick these things, it'll get rid of them. Yeah. Now it's starting to look a little better. Get rid of that. Uh-oh. I got rid of my point. Where was my point? This one? No. Why do they try to what? Oh, there it is right there. Incenter. All right. So I didn't want to get rid of the incenter. I want to keep the incenter there. All right. So now, there is something special about the incenter. Which one of these things that we've done so far, there was nothing special about that point, that concurrent point? The orthocenter, okay? The orthocenter, there was nothing special about the orthocenter. It was just there, all right? But there is something special about the incenter, all right? Is it, I'm asking you a question, is it the same distance from here to B, here to C, here to A? Well, I'll tell you what, let's do this. Let's mess around with this triangle a little bit. Is that incenter the same distance to all three vertices? No, obviously not. I could put the lines there and then figure out how long the lines are just to show you that no, it's not. It's not the same distance to each vertex. Look, from here to C is a lot shorter than it is from there to A. Agreed? All right, so it's not that one because that one's the circumcenter, right? The circumcenter is the same distance to each of the vertices. But what's true about the incenter? Okay, let me do this. What I'm going to do is I'm going to draw a perpendicular line from the incenter to each of these three sides. All right, you with me on that? All right, so I'll show you why I'm going to do that in a second. So let's go just perpendicular line. So what I'm going to do is go from here to here. There's my perpendicular line. No, I'll show you why. Because basically my explanation just a second ago showed you that the circumcenter and the incenter were not the same thing. Because remember, the circumcenter is the same distance to each vertex. Is that incenter the same distance to each vertex? No, I just showed you it wasn't, right? Like right here, it's kind of hard to tell. But yeah, that definitely looks shorter than that one, doesn't it? Yeah, so the incenter and the circumcenter are not the same thing, all right? So what I'm doing here, I'll show you why in a minute, okay? Let me just do it and then I'll show you. What I'm trying to do is find the distance from the incenter to the side AC, all right? You see that? All right, I'll do the distance here in a second. All right, I'm just going to do this the rest of the time. I'm going to go perpendicular to this side right here. So I'm going to go from the incenter perpendicular to this side. Everybody got it? Then I'm going to go from the incenter to this side right here. Now, why did I do that? I'll show you. What I want to do, I think I can just do segment. Let's do segment. What I'm going to do is click here and click right there. All right, so I got me a little line segment. I'm going to do that to all three. Watch. I'm going to go from the incenter to this point right there. See, that gives me see, that's point D, that's point E. Now I'm going to go from the Incenter to this one right there. I'll show you why I'm doing this here in a second. All right, do you see those points, D, E, and F? Let's put this D on the outside so you can see the D, you can see the E, and the F is a pretty good spot right there already. All right, now look at those distances from the Incenter to D, the Incenter to E, and the Incenter to F. Take a wild guess. Tell you what I'm going to do. Let's get rid of those big long lines right here. So let's get rid of that one. Let's get rid of that one. And let's get rid of that one. There we go. That looks a lot better, doesn't it? A lot cleaner. All right, check this out. The distance from the Incenter to that side, the distance from the Incenter to this side, the distance from the Incenter to this side. What does it look like they might be? The same. Exactly right. Watch this. I could take this triangle and change the shape of it. Look at those three distances. They look like they're the same, don't they? No matter how I move this triangle around, I could take this angle and move that one around. Look at those three distances. They all look the same, don't they? All right, let's see if they really are. So I got a thing on this program that tells me the distance. So what I'm going to do is right there. It says distance or length. Click that. Click this little line segment. Boom. That one's 3.4. Take a wild guess. What do you think it is from the Incenter to E? 3.4. What about the Incenter to D? 3.4. Okay? Just they are, right? So this shows you that they are even. You got to believe the program, all right? If you don't believe the program, then I don't know what to tell you. But if you believe the program, they are the same. What if I change the shape of the triangle? Does that change the, well, it'll change the distance, but what do you think is going to stay the same, though? The lengths, right? The lengths are all going to stay the same. Look, I make it smaller. Look, they're all the same, aren't they? Move it like this, move it like this. Let's take this side and extend it out. Look at my lengths. Okay, they're all the same. That's what's special about the Incenter. The Incenter, it's not the same distance to the vertices. What is it? It's the same distance to the what of the triangle? To the sides of the triangle. That's the big difference between Incenter and circumcenter. Everybody see that? All right, so the Incenter is the same distance to each side of the triangle. What is the distance from a point to a side of a triangle? It's the perpendicular distance. That's why I made them perpendicular earlier. With all those lines flying around the place, okay, that's why I made them perpendicular. Everybody got that? So, let's review. How did I get the Incenter? How did I get the Incenter to begin with? What did I have to do? I had to bisect each what? Each angle, okay? That's how I got it. I got rid of those lines because it was just too messy, okay? But how did you find the Incenter? You bisect the angles. Then I got my Incenter. What's special about the Incenter? It's equidistant, or the same distance to the what? To the sides of the triangle. You with me on that? We're going to write it down here in a second just so that you know, all right? So that's what's going on. There's one more thing. It's not that big of a deal. This is why they call it the Incenter. We did this with the circumcenter yesterday, all right? Remember I said I forgot to do this on the first, what's day? When did we start it? On Tuesday? So we did the circumcenter on Tuesday, and I forgot to do it yesterday, which is Wednesday. What did I do? I made a circle. What happened to that circle? That circle went what for a circumcenter? You remember what I did? It went around the whole entire triangle. Remember that? It went around it. We had a word for that. Anybody write that down? We say that circle was what? Circumscribed about the triangle, or around the triangle. Okay? That means it went around the triangle. And each point, each vertex on my triangle hit on that circle. That's kind of important. That's why they call it the circumcenter, because it goes around. Why do you think they call this the Incenter? Because the circle is going to do what? It's going to go inside it. So let's do that, all right? I've got a thing right there. Circle, actually, let's see. Is that the one I want? I think it is. Circle with center, I think it is. So watch. I'm going to click right here, and then I'm going to make my circle. Check this out. Let's put it right there. Isn't that cool? Look at that. So the circle, okay, if I extend it out, each one of these is the radius of the circle, isn't it? See that 4.2, that 4.2, that 4.2? That's the radius of the circle. Where does that radius fit? It fits where? Inside of the triangle. Let's make this a little smaller. Let's just see. Do this. Actually, let's try this. Stupid me. Let's try this one more time. Wonder if I can... I got to get rid of that. Okay, let's try that one more time. Remember, the circumcenter goes around the whole thing. But look at this one. See, look, I can let it hit at 2 points, but look at that one. Does that lie right on the circle? No. So the incenter is not the same as the circumcenter. What did the circumcenter do? When I made the circle, each one of these vertices lies right on the circle itself. Okay? So I'd have to start from another point somewhere, wouldn't I? I'd have to start from the circumcenter, which I don't have. So this doesn't go around the circle. What's it? Let's try this again. What's this do? Starts from the incenter, and it just hits each of these sides right on the triangle itself. Okay, everybody see it? So that's why they call it the incenter, because when you draw a circle from it, it's inside. It's perfectly inside of that triangle. All right. That's just kind of nice to know. I mean, that's not anything you're going to have to know on a quiz or a test. I just think it's kind of interesting to see circumcenter, which means a circle would go around the triangle. Each point on the triangle would hit the circle itself, okay? But the incenter, it's a point where you take a circle out of it, it's going to hit right on the sides of the triangle, all right? I don't know. You don't seem as interested in it as I do. Okay, I think it's kind of cool to see how that works out. Okay, that's a special point right there, that incenter. It's not just any random point. Watch, for instance, if I just put any random point right there, and then I did a circle from that random point, okay, look, it's not going to fit right inside that triangle, is it? You see that? Will it go outside? Nope, look, it hits 1 point, but there's no way. Look, I might be able to get that hit. Now, it still doesn't even hit 2 points, does it? All right? So these are not just random points. These are specific points, and we found them by specific reasons, specific ways. All right? Again, one more time. I'm going to write it down in a second, but let's just verbally say it. How did we find the incenter? What did we do to find where that incenter was located? We bisected the what? The angles. Very good. Okay, so once we bisect the angles, they all come together at 1 point. That point is called the incenter, all right? Now, what's special about that incenter? That incenter does what? It's equidistant from the sides of the triangle. That's right. It's equidistant from the sides of the triangle. How do I show the distance from a side to a triangle? Is it like from here to here? Is that the distance? Is it anywhere from here to here? Say it, I heard it. It's perpendicular. That's right. It's from the incenter perpendicular to that side. That's the distance. That's the length from a point to a side. It's always the perpendicular distance, which is really something that we talked about yesterday. What word did we use yesterday? I don't want to make this too confusing, but it's so cool that a lot of this just fits together so nice. What's the word we used yesterday to find the orthocenter? What did we do? We found the altitude. We found the altitude, didn't we? Okay. What is this? If I go from a point perpendicular to a line, that's the altitude, isn't it? So really, these three are the altitudes. Okay. So it's just kind of cool to see how that works. Let's go back to this program right here. And I got to switch it up. There we go. All right, so let's write down a couple things and we'll be done. And then we can look at your homework. So we're just going to talk. We're not going to review anymore. Okay, I've done enough of that review. Let's just talk about today's subject, the incenter. How do you find the incenter? Okay, you bisect each angle, okay, of the triangle. Everybody got that? That's how you find it. Now, what's special about it? What's special or unique about the incenter. It's equidistant. You okay if I say that? Equidistant? That should make sense, doesn't it? What does that mean, equidistant? It's the same distance, right? It's equal, right? We don't put the L in there, but it's equal distance. By the way, it's EQUI, not EQU what? A lot of you guys have been spelling it EQUA, all right? It's not equilateral, equiangular, equidistant. They use the I, equidistant, okay? Just so you know how to spell it. All right, so it's equidistant from the what? From each side. Let's just say that. From each side of the triangle. Okay? I'll just say each side. All right? So that's really, really important that you know these things right there. Know that about the incenter. Know that about the incenter. Okay? That they bisect. How do you find it? You bisect each angle. What's special about that point? It's equidistant from each side. Everybody with me? All right. It's a lot to keep straight, and we still got one more to do, all right? Tomorrow's is a little bit different. The special thing about it is just a little bit different. Probably that's why they save it to last. I don't know. But anyway, I just think it's kind of interesting. Without getting like too super spiritual on you, I think this doesn't just happen. I think God created this, right, to happen. I really do. It's just amazing. It's not just happenstance. It's not like, oh, that's kind of cool. No, I mean, God did it. He put this stuff together. I mean, he designed this stuff right here, the little tiny details. It's absolutely amazing. I watched, when do we get out here? 30? All right. Do we have time?
Yeah.
14 minutes. You may not want me to do this. But don't be too... but there's a video I watched last night, and it's about pie. Let's show it. It's Pie Day. Do you know it's Pie Day today?
Yeah, we just had some crazy Shang in the other room.
Crazy who? Shang. Is that what you said? S-H-A-N-G? Is that how you... Shang? All right, that's a first. I haven't heard that one. You guys heard of that? Shang? I've never heard anybody say that. Did you just make that up? Or people actually say it? People say it? All right. I got to keep up with all this stuff, so I know. By the time I finish speaking or finish teaching, I'll know a whole completely different language, I guess, with all these things. But in about a week, nobody will be saying it. I don't think anybody says it now, I'll tell you the truth. Shang. What's it mean? Good food. Is that what it means? All right. I had some Shang last night. Is that how you say it? Is that how you say it? Or you just say the food was Shang? How do you say it?
Yeah, you said it good right there.
You can say it either way, it's fine. All right. I got a sub. It's supposed to be a free period. But I got a sub for 11th grade next period. Ask them. Okay. I had a chicken quesadilla from this little taco stand on Route 40. Has anybody been to that? There's a little taco stand tucked back on Route 40. And man, they make the best food. And so I always get a chicken quesadilla every single time. And it was just so good last night. So I got leftover. So I'll have that for dinner again tonight. But anyway, that was good. So that was... Can you say it was Shangin'? I'll make that up. That food was Shangin'. I'm going to start saying it. I don't care. It'll be my thing. All right. Enough nonsense. Let's... I'll show you a little bit of the video. Is that all right? Okay.